How do we figure out the harmonic calculations in a building? Well, at Mulcahy, for those of us that actually do it, we use ABB's harmonic calculator. I mean, yes, we are tied in with ABB, but after looking at their harmonic calculator, some of the other brands, in my opinion, this is actually the best and the easiest one to use, and anybody can use it, and it's one of the cheapest. For example, or for instance, it's actually free. If you go onto their website, onto that web page right there, you can download it for free. It is Microsoft Excel based, so you don't need an additional program. It'll just run right off of your Microsoft Excel page. Once you go on that web page, scroll on down, click on that tool, and it starts downloading it. Once it loads up, this is what you're going to see. If you notice on the bottom, you got 4 tabs there. The first one being instructions. So it even comes with its own instructions. Don't have to go find those somewhere else. But as you scroll down the page, you'll see it shows you about utility power and what you need to know for that. All the default values, any values you can change. And then further down, it shows you that you can adjust for, or you can calculate for generator power as well. You put the information in you need to know for that. And then the tab to the right is the input. So that's where you're inputting all your data. And so this is what you'll see initially. And actually, I'm going to tell you right now, I just realized, or I just found out that that page that I have on there is slightly different. They actually are updating it right now on their website. So this is an older revision. It's missing one little spot in there that has to do with putting in linear loads. But anyways, so you can put in the name of your project, you can name it or label it so that if you want to print it off and hand it to someone, you certainly can. You got your utility information, the spacing for your drives, and a quick view of how you're doing. So the first thing you're going to do is enter all your utility data. Remember, we are looking at the point of common coupling. We are looking at the whole building, not just a specific piece of equipment or a specific area in that building. So what we need to know is, what is your utility voltage? What is your megavolt amps? Short circuit. What is the rated kVA of the transformer? Are we going to be doing this on the primary or secondary side of the transformer? And if you want to do your generator instead, you just click on utility there. It becomes a drop-down tab. And then you can actually, the blacked out portion will switch over and you can work on your generator calculations. So once you get all those calculations in, now all you got to do is enter your data for the drives you're going to be doing. You can ID tag everyone, whether you're supply 01 or exhaust fan 3 or whatever it might be. You put that in there, and then you can pick a drive in the drop-down menu. You'll notice they give you a lot of options. This is not ABB specific. If you want to do Danfoss or Yaskawa, it's certainly capable of doing that for you, so it gives you all the options you need there. If you want to do a drive with an additional filter, you can. On the second line there, I have an ultra-low harmonic drive, just so you see. If you got a drive filter combo that doesn't work, it'll let you know. So it's really, really nice in that matter too. So this is a particular project that we were working on up in Duluth for a hospital. Right now we have 6 pulse drives with 5% impedance, which is that second drive that I showed you earlier. And what you'll see when we look at the quick view, as we entered all those drives in, we were still failing. So that's an example of where that harmonic distortion reduction that we had is not enough. Over under value over there, right around here, you can see our total demand distortion limit is 8%. So that's what we're trying to get below. How do we know what that limit's going to be? Well, when you enter that data into your utility information, this program will automatically figure it out based on some tables that are in 519, 2014, and it'll enter that in there automatically for you. So we know we failed. We're at 20% right now. So one of the nice things about this calculator is if you failed, you can go back, start adding filters. A really cost-effective way of taking these particular drives and making them reduce the harmonics even more is adding a 3% or 5% line reactor to them. So what you can do is you start with the biggest offender, the 200 horsepower unit that's up there. Start adding filters, and you can work your way down until that total demand distortion, okay, fail, and your limit there actually reaches that 8%. So it'll adjust as you're changing those numbers. So with this particular project, we actually were asked to put ULH drives in. It's probably about 2/3 of the building. And they just wanted to know, will this pass? Because we're not going to use ULH for the whole thing. We just want to do ULH and then the standard drives without extra filters. So we entered that all in. And as you can see, we are at a total demand distortion limit of 3.12%, and it passed. So now that we know we did what we wanted to do, we met our goals, we want to print a report. So we got 4 pages that it'll print out. The one on the far left is your whole summary and whether you passed or failed. The second one over is all the equipment that you have in there. The third one is our current and voltage distortions. And if you notice, that looks similar to those bar charts I already showed you once. But it's missing that fundamental current. Well, if we had that fundamental current, that thing would be up at the ceiling. Because as you can see, the fifth harmonic there is only at 2.5%. So there's hardly any demand distortion on this whole system. And then the fourth one is actually all these numbers. If you look at it, it's just the numbers of what this bar graph really is.